Okay. Good afternoon. Welcome back. This is now the second panel discussion of the day, and the topic will be international competition in physics. This morning, of course, our first panel had a spirited discussion of collaboration, but now we're interested in what happens when the groups are smaller and there's a lot of competition between them. We have six scientists from around the world and also from the US, and I'm looking forward to a good discussion. They're an impressive group, they're a diverse group. I really feel kind of humble among them. We've got some former leaders of national science policy. We've got research leaders in multinational companies, experts on nuclear non-proliferation. We also have a number of us who are sort of in the trenches, that is, in competitive areas that cross national boundaries. We all had a chance to meet earlier today, and so now let me introduce them all to the rest of us. First, sitting just to my right is Sir Peter Knight, FRS, that means Fellow of the Royal Society. He's a British physicist, professor of quantum optics, and a senior researcher investigator at Imperial College, London, and principal of the Kavli Royal Society International Center. He's a leading academic in the field of quantum optics, and he's the recipient of several major awards, including the Royal Medal from the Royal Society and the Thomas Young Medal and Prize from the Institute of Physics. He's also a former president of the Institute of Physics and former president of the Optical Society. And for many years, he's been one of the UK's most influential and respected thinkers on both domestic and international science policy. Now, sitting just to the right of Peter is Petra Rudolf. Petra is a German and Italian solid-state physicist, and she's a professor at the Zernike Institute for Advanced Materials at the University of Groningen in the Netherlands. In 2018, she was elected president of the European Physical Society, and prior to that, she was president of the Belgian Physical Society. She's been a leading activist in efforts at diversity, equity, and inclusion in the sciences, and she was recognized by the 2018 Diversity Award from the Netherlands Physics Association. She's also been active in research on building synthetic nanomachines, and her research group shared the European Union Descartes Prize for their work on molecular machines as part of the SynNanoMotor multinational consortium. Sitting now to the right of Petra is Andrea Liu. Andrea is the Hepburn Professor of Physics at the University of Pennsylvania. She's a leading theorist in the field of soft and living condensed matter physics and is known for developing the field of jamming. She's a member of the National Academy, and this year she is the speaker of the APS Council of Representatives. In that role, she's become a leading advocate on the topic of the US climate for Chinese and Chinese American scientists. Next is Professor Siegfried Hecker. Have to switch back, sorry. Dr. Hecker is a metallurgist and a nuclear scientist. He served as the director of the Los Alamos National Laboratory from 1986 to 97. He's currently research professor emeritus in the Stanford Department of Management Science and Engineering, and he's also a senior fellow emeritus at the Freeman Spogli Institute for International Studies at Stanford. He was co-recipient of the 2009 Enrico Fermi Award, which is one of the highest presidential awards for science. Professor Hecker is one of the leading US experts on North Korean nuclear arsenal and attempts through negotiations toward the goal of denuclearization. Next is Mr. Craig Mundie. Craig Mundie is the president of Mundie and Associates. He joined Microsoft in 1992 and retired in 2014 as Chief Research and Strategy Officer and Principal Technology Policy Executive. and he currently has an advisory role in more than a half dozen high-tech companies, and he advises the Microsoft CEO, and he oversees Microsoft's quantum computing program. Craig Mundie served Presidents Clinton, Bush, and Obama on the National Science and Technology Advisory Council, and he was on Obama's President Council of Advisors on Science and Technology, PCAST, for both of the Obama terms. And then finally, sitting all the way to the right is Professor Steve Chu. And I think Steve Chu, because he was introduced extensively in the morning, I don't have to say too much. I'll just say one thing by way of introduction, and that is Steve Chu. The reason that I am exactly in the career position I am is that when I was looking for graduate school, Steve Chu was actually the individual that convinced me to go to Berkeley. So thanks very much, Steve. Okay. So thank you all for joining us. I'm really interested in what we all have to say on the subject of international competition, and to kind of set the table, I'd like to start by kind of winding back to something that Steve described in his talk, but it's very important, it's central to what we're doing here, and that is this document with the odd name NSDD 189, which is the guidepost for fundamental research openness in the United States. Steve?
So, okay, thanks, Phil. So very briefly, since I read you some of the issues, let me just summarize it and tell you what the issues are. Very briefly, it defines fundamental research as any research in science or technology, both basic and applied, that is going to be published in the open literature. And the Reagan position was that if it is in this realm, virtually nothing should dissuade or slow down its dissemination. So I'm just paraphrasing what this is saying. So then the question is, in today's world, given that there are some real threats of getting 2 or 3 or 4 year earlier glimpses into research that then can be used that be filtered back to other countries before the group is ready to publish, so they can get a head start. This is blatantly just simply unethical behavior, but what safeguards should one have, and is this realistic? I believe it is, but that's a point of discussion. So it's just open to discussion. How do you keep this open research, recognizing the threat and recognizing that this thing is happening and the progress from basic research to economically useful things is accelerating?
Yeah, so Peter Knight, I guess this is one of the big areas we just heard from Chris, is quantum information science. Maybe you can describe how this is playing out in that sphere.
Yeah, I guess that one of the expectations of government is always that one seeks to reap a reward for investment in basic science in some way. And there's a growing acceleration of movement out of laboratories into things of economic benefit. And it is something that you see accelerating right around the world, that the policymakers do understand the need for investment in basic science, but want to make sure there are vehicles in place by which the technological applications of this grow. And quantum information science is a very good example of this. And Chris, in his talk before the coffee break, I think really did talk about this quite well. If we think about the science side of it, what do we characterize in terms of science? Open, collaborative, a concentration on excellence, and in particular, the acquisition of the best talent. And that's where competition internationally is really quite important, because the best talent means the best talent globally. I'm really quite pleased that the UK government on Monday announced a thing called the Global Talent Visa process, which was to attract the best scientific expertise from around the world to come and work in the UK. To control the visa process, we got them to agree to move that control process out of the hands of the government departments into our research councils. And our research councils will then play a role in identifying the strategic role that a young person could play within the science arena. And I think this is a really welcome development that was announced on Monday. So that's the idea of the science side of it. But what about the technology side, where we have to identify prosperity? That means then confidentiality, to some extent a kind of focus into a closed environment. Nations would worry about sovereign capability, and then they have to face the challenge of what that really means in a world of multinational companies. It means that we have to worry a lot about IP protection, as we've heard. We've heard quite a lot about malevolent acquisition of IP, something that has not been mentioned at all, and I thought, as a European, I ought to mention it here, is that the United States puts some constraints on the ability to commercialize some technology if there is US involvement in that technology. And this process is called ITAR, and the fear of ITAR, not perhaps the reality, but the fear of ITAR sometimes contaminates the ability to work with the US. And this is something that we need to deal with, because if you have a collaborator from the United States within your national program that's doing something on commercialization, in some areas you may not be able to commercialize that in an appropriate way. So the fear of ITAR is really quite worrying. And I think that in terms of quantum information science, we heard a little bit, for example, from Chris, about going beyond just quantum computing, quantum sensors, quantum communication, smart cameras, and so on, where there is always going to be dual use. And that's where we need to work out how do you capture any sort of insights and what dual use might actually mean. And I think that's something the community is really struggling with.
Thanks. I really want to pick up and continue discussing this issue of the connection to multinational companies, because multinational companies are not purely U.S. companies, and so all of these issues become very complicated in the sense they're on both sides. Maybe Craig Mundie, since you've had a lot of dealings with Microsoft and still have, you can illuminate us on that.
Yeah, I think some of the things that Peter just mentioned are really coming into focus in this multinational corporation environment, the dual use question in particular. In fact, I think there's several trends that are really confounding these issues. One was mentioned, the acceleration, the shortening of the window between discovery and commercialization. The second is many of the things that governments used to think about as security issues were more or less in the defense and intelligence space. And oftentimes the technology was developed by them and paid for by them, within a sovereign environment. Now what's happening is companies, big and small, and particularly the multinational ones, are doing some of this research and developing these technologies with no government funding. And the governments only realize ex post facto that these things have direct applicability in military and intelligence environments. And that leads them to want to retrofit a model of regulation on these things in terms of export controls and other things that really were developed over decades of them controlling the trickle down from their own investment. And so, all these things are getting inverted. Acceleration, sort of an inversion of when things become dual use and how that flow happens. In the case of the companies, it's very difficult because you have to obey the laws of each sovereign country in which you do the lab work. But as far as the company's concerned, it's just one company, and you largely, divide the work across the capabilities of all the labs.
So I imagine then, restrictions on travel between labs that are in different countries are internal restrictions from the point of view of the company.
Interestingly, inside the company, there's less constraint on getting visas, to go from place to place within a company. It's not perfect. I mean, we do end up having certain meetings. But the other thing is, most of our work now, like in the quantum program at Microsoft, we have labs, in Finland, the Netherlands, Denmark, the United States, Australia, and we all have meetings. They're all virtual. Nobody travels. And so to some extent, there's almost no visa issue unless you want to try to put visas on the bits, because the collaboration is happening continuously. And as a result, it's just sort of outside the conventional models of control.
Let's get back to something that you mentioned, which is the federal government discovering that there's a nuclear security angle to things that are going on. Sig Hecker, you were Los Alamos director, which is a national weapons lab for a number of years, and probably had to face on a daily basis this division between military sensitive and open research.
Yes, indeed, in the national security arena, and particularly at a place like Los Alamos, where the main mission from the beginning has been nuclear weapons related. So we faced that whole spectrum for the entire history of the laboratory. And I think what's important to understand as to how we've dealt with that is for people to have a better appreciation for what actually goes on in these laboratories. And I would say that was sort of the most difficult job I had in dealing with Congress. Because for the most part, especially if there was any sort of a security problem or a potential spying problem, Congress would come down upon us and said, for heaven's sakes, can't you protect your secrets? After all, I mean, we lock up the gold bullions in Fort Knox, and we know how to lock that up. Why can't you guys protect your secrets? So we had to explain to him that we have to create the secrets. We create the secrets, and to create the secrets, you need a totally different atmosphere than from locking them up. And particularly what you need is that whole spectrum from the fundamental sciences to the applied sciences to the application. And in this case, the application is serious business, nuclear weapons and nuclear deterrence. And so that's what we struggled with, and that's what Los Alamos has been from the beginning. And what do you need to do that? You do need fundamental science. And you also needed people that are the best at whatever they do, and that goes all the way back to the Manhattan Project. Enrico Fermi was considered an enemy alien while he worked at the University of Chicago. And then you look at all of the rest of them, from Johnny von Neumann, to Wigner, to Bethe. I mean, we brought the brains from around the world. We welcomed them to the United States, and they helped, develop the atomic bomb to end the war. Well, it didn't just stop there. We had to continue to try to get the best people. And for example, in my case, during my directorship, 86 to 97, it was one of those moments that Steve Chu pointed out this morning, where we more or less got a gift. It was 1989 and Tiananmen Square in China. And so what happened, you had this incredible influx of these bright, bright graduate students that came in the United States. So then in the early 1990s, since I always felt it was crucial for Los Alamos to have the best possible people there, we needed to have the best students and the best postdocs. And so Los Alamos was a big place, 10, 12,000 people with contractors. And we had 1,500 students and 400 postdocs. Well, in the early 1990s, I caught an enormous amount of flack from Congress that out of those 400, 100 were Chinese nationals. And they said, how could you possibly have Chinese nationals? I said, because our mission is to have the best possible people work at the labs. Our mission is not just a nuclear weapons mission or stockpile stewardship, but it's to guard against technological surprise. What's out there? What's there? And you have to have smart people. And right now, 1/4 of the best graduate students in science and technology in the United States happen to have come from China. That's why we have them there. And we had a system at Los Alamos of what I call short fences and high fences. Keep as much of the laboratory with short fences. And then the stuff that's really, classified, you put high fences around them. But don't put a high fence around the whole place, because eventually you won't need a fence because there'll be nothing left inside that others will want. And so that's the key.
Andrea, let's fast forward from the wonderful time when, not wonderful for the Chinese who had to escape, but wonderful for the science community in the US. But then to today, where there still are many of the best, you and I and a number of us who try to admit the best every year to our graduate departments, find that they're Chinese and they really should come here. And tell us a little bit about what the Chinese graduate students are feeling and experiencing now.
Oh yeah, there's a feeling of tremendous vulnerability. And so, for example, I have a postdoc who has not gone home in 8 years. He came here for graduate school. He has not gone home since he came because he's afraid that if he goes home, he doesn't know what kind of delay he'll experience in coming back. You know, we're part of a collaboration with many people in France. We have meetings every 6 months, you know, and we meet in Paris. He cannot go, right? So it really hurts. And I just want to raise something that hasn't really come up yet today, which is the dangers of the current climate to small-scale science. For example, condensed matter physics. I think it's absolutely devastating. And the reason why is because in condensed matter physics, we have small groups, okay? It's grants, we have individual grants, it's every person for his or herself, right? For him or herself, and so, you know, we're totally on our own, nobody has our backs. Funding rates, for example, at the NSF are now 10 to 15%. So you put this all together. Suppose you have a student who goes home, parent is dying or something and really wants to go home, then they get tied up for 9 months, sometimes a year, and can't come back. You cannot get the research done, right? That's the end of your grant. You cannot get it renewed. And that could be the end of you as an active researcher. So I think that's I mean, we're really facing, I think, a really dangerous period, and I think in many ways it's worse for small-scale science. Let me say one other thing. You know, we write all our grant proposals, we do everything, we have very little administrative assistance, and that means when something comes up, for example, many people, because of the bad funding situation, are tempted by the 1,000 Talents program, right? And took money for China to support their research. Okay, you know, they had to make all the decisions. What's the right thing to do? How do I report this? They had to do this all on their own. And, you know, some people have made mistakes and will pay for that by losing their jobs, right? And so I think we have to recognize that I think it's maybe even worse for small-scale science than for large-scale collaborations.
Petra, Rudolf, I think we'd all like to hear the European experience as well, because many of the Chinese students, of course, go there.
Well, that is a recent development, of course. Before, Chinese students would very much look at the rankings, and then even if we were at the same level in the rankings as the American universities, they would still choose the American universities. And that is less the case now. So we see that we are getting, just to give you a number, in my own university, which has a total of 1,000 PhD students for all branches of science and engineering, we get about 40 to 45 financed by China per year who start a PhD with us. And it has been a learning process because they are financed by China, so they are wonderful talents who come and work with us. But their situation is not so simple because we also know that they have people who get instructions from we don't know exactly who, but there are certain leaders in that group. And when somebody of these leaders has finished, somebody else takes over that role. So they are not entirely free when they are with us. That is something that we have learned. On the other side, there is also some pressure from home because their parents have put something like $35,000 on a blocked account, and they can access that only when their son or daughter comes back with a PhD. These are all things that they don't tell us, but we find out over time. And we try to take that into consideration in the way we supervise them. So for example, we now have instructions for our supervisors how to select and supervise your Chinese PhD students, which is essentially a crash course on Chinese science culture and the way, what do the Chinese students expect from us. We have a mediator who speaks Chinese and interferes when there are problems between the supervisor and the student. So on one side, it's a blessing. On the other side, we had to adapt to it as well. And it's for them not so easy as well.
Steve?
Can I just jump in quickly? First, with Andre, what you said is also true. I do small-scale science. It's really small-scale because one postdoc working on a lithium metal sulfur battery, 2 people working on neurotransmission, 1 person working on electrochemistry. I only have 6 people, okay? This is really small scale. One of my postdocs got married to, he's a Caucasian, got married to a Chinese woman. They decided to have a, quote, honeymoon in China for a month, and everybody was holding their breath, whether they're going to be there for a month, 2 months, 6 months, because that whole, what he was working on, which is ultrasound, would have been shut down. And so it's also true of small-scale companies. You can have one big happy family if you're Microsoft, because there are very few players who can compete with Microsoft. But if you're a small battery company, or if you're a small biotech company, I'm on the boards of these 2 companies, if someone steals your prize jewel secrets, your trade secrets, or rips you off in a patent violation, and they say, so sue me. So the vulnerability in both policy and both the negative and positive is so much higher. So the stakes are higher. Microsoft is protected because they're big and strong. And the quip I made about, with high energy projects, it takes 10 years to form a committee to decide what to do, to get it started. There is an inertia. Well, I didn't mean to sound not respectful, but there is an inertia with large-scale projects, and there's an inertia that also gives you some regulatory protection. And this is not true. And you put that together with this quickling of the pace of progress, and it becomes even more delicate.
So at one level, it seems like a huge amount of pressure is being put on the Chinese student, as an educator, of graduate students, you have a kind of, in a way, it's kind of a parental feeling. I mean, certainly it's a mentor feeling that you don't want to subject them to unnecessary harm or stress by creating a bad environment. So, what are the effects of some of these proposed restrictions and changes on travel to meetings and that sort of thing on these students? Are you seeing in your labs that the students are voting with their feet and leaving the U.S. and we're actually losing out?
I mean, statistically, it's certainly happening. It has not, and I think there are certainly a lot who are just choosing to go back to China instead of trying to make careers here, even very, very good ones. They don't even try. They used to always want to try. I mean, just to give you one example of something that came up. So my postdoc, he's been here 2 years, want to extend him. We had to go from a J1 to an H1B. Okay, so I had to write a description of what he's going to do. And I mentioned in my description that he's going to use machine learning methods to look at, glassy dynamics. And, he came to me like a couple days later. He said, what did you say in my description? Did you mention machine learning? And I said, yeah. And he said, uh-oh. because what he's hearing from his friends is that if you mention the words machine learning in a H-1B visa application, it could lead to a delay of a year or more, or lead to just outright, a no. And so I changed it. I said he's going to use dimensional reduction methods to look at galaxy dynamics.
Some of the restrictions are sort of in the lab. I get, in a sense, even theorists have labs because they have software packages, and there are these deemed export restrictions on sensitive technology. So how much is that affecting the research environment right now? Anybody want to comment on that?
Well, it's dicey because one tries behind the scenes to not prevent things from happening. I was successful in this respect. After I came out of Department of Energy, I wanted to develop some things where I needed good cameras, more sensitive in the infrared. There are 3 manufacturers, Hamamatsu, Ondor, and Princeton Instruments, who make these cameras. The chips at the heart of the camera is being made by a foreign company. And what was circulating in the Defense Department Commerce was an idea saying that this is going to be forbidden technology. And I had to use all my connections in state and defense, literally, as in, like undersecretary, to say, wait a minute, the competition, there's one company will be punished, it will be Princeton Instruments. Hamamatsu is Japanese, Andor is British. The chips are made in a company. We don't own this technology. So what are you doing? And because if you declare that as a sensitive, then no person from a sensitive country is allowed to use that because it's deemed export sensitive.
We see exactly that, and Andor, which is a component part of Oxford Instruments, has really flourished because of the restrictions on other things. So your restriction process within the United States has enabled a foreign country to develop a technological capability faster than they would have done otherwise.
I know. So you're getting your revenge for all the Brits that we stole in the United States, and now they're rolling this out, so they're going to steal Americans.
I forgot to mention at the top, and I really should have, that I know a number of you want to participate in this discussion by asking questions. So you do have cards. You can write down a question, pass it to the front. Alex or one of the other staff will pick it up. I want to make sure before the end of the 90 minutes that we get some participation from the audience. And if that doesn't work, I'll start asking for hands.
I'd like to bring up something. Oh, go ahead.
Phil, if I may, let me just sort of add an experience from the national security side in relation to this issue of restrictions or classification and so forth. So certainly my experience at a place like Los Alamos is that, generally, I would almost say that our world is sort of easy compared to the commercial world because there is something called classification. And it turns out the classification part is actually reasonably straightforward. I know what's classified in my business and I know what's not classified. Problems come in a couple of ways. Is that there's a tendency of the government to go into the protect mode, and that is to over-classify. And it's simply not appreciated that when you overclassify, you get less people, you get fewer ideas that come in to help to create the secrets. And so this balance between creating the secrets, protecting the secrets, is absolutely crucial in this business. I found without question, the more you protect, the more you classify, even on stuff that's sort of borderline or questionable, which again is what the government would tend to do because they're in the protecting mode, is you wind up simply not getting the right people. When you write up your reports, your classified reports, when a classified report is in the safe, it is accessed, only a fraction of the time that an open report is accessed. And so that whole environment can breathe, and then particularly if you get into top secret or compartmentalize the information, in that world, and there are few people that are actually looking at those crucial problems. And so one has to make sure that you constantly look at the balance between creating and protecting. And that's very difficult to get the government to accept that.
Andrea,
Oh,
and then Petra.
Yeah, so this is changing the subject a little bit, but I did want to, in the last several months, I've talked to a lot of people who have received funding from China who work here, many through the 1,000 Talents program. And just want to say, it is really striking the level of fear among these people. And many of them would not communicate with me by email, really wanted to talk only by phone to tell me what they thought. And for a lot of them, all of them say, the rules are changing. The rules are changing on them. What was considered perfectly fine 10 years ago is now considered a problem, and what they did was wrong. They didn't know that, and now they're getting into trouble, or they might get into trouble. So, yeah.
So trouble for something that's sort of illegal after the fact.
After the fact, and especially among those who are originally from China, the level of fear is really astounding.
Yeah, from a European point of view, this fixation on China is a bit difficult to understand because PhD students from India, they see the same research environment, people from other Asian countries as well. And why not? People from the States who work in Europe and on their postdoc, they also export scientific knowledge from the good labs. So I must say that among the people in basic research in physics, it's difficult to understand why there is this fixation on China here in the United States.
Well, for example, you brought up yourself that the Chinese students seem to have a level of someone minding them. I think that was what the word that we used. And do you find that, though, with other international groups?
No, not really.
I think that's one of, from the U.S. perspective, that is definitely one of the reasons that we're so concerned. Yeah, Craig.
Go back to the point Sid made. I think one of the differences between the commercial environment and sort of the academic meets national security issue is we get to make an individual decision inside the company about how we want to balance these risks. And so, we understand, what its potential is in the grand scheme of things. We understand and can control where it gets done in the company, which is essentially where it gets done around the world. And you can blend these things together and even, use segmentation, if you will, within the company to control pilferage. I think one of the real challenges here is that when somebody starts to try to write rules, it's very hard to write general rules that allow you to make those kind of judgments. And so they tend to encompass too many things. And we don't have a good way to adjudicate the real value of what these things are, or what the real downstream risks are likely to be, if the information gets spread around too far. And so I think that this is one of the real dilemmas in the context of all of these things getting compressed in time. The discovery to commercialization or application in the defense or intelligence sectors are all collapsing in time. The people are only discovering them when they see them, and they emerge out of something that wasn't, with years of public, published research and a lot of people understanding it. It's like these things just come out of nowhere. And I think the surprise element there makes it even harder. And so the lack of familiarity ends up resulting in much broader rule writing or the desire to write very broad rules, whether it's by nationality or, you know, domain, like quantum information. You know, I mean, well, that's going to cover a huge array of things. You know, you really want to stop all of it? You know, is quantum key distribution like as important as certain elements? Are the software algorithms for quantum computing that no one has yet, are they more valuable than the machines themselves? Who knows? But if you just put, like Chris said, if you just put the word quantum in front of it, if you're trying to raise money, it's good. If you're trying to do research, it's bad. You know, if you want to do it on a global basis or particularly if you wanted to do it in or with Chinese at this point.
Good. Phil, I want to pick up something you said, and this has to do with the fact that nowadays, recently, there are people kind of watching. You know, in the old deep dark days of the Soviet Union, right, the few times Russian scientists were allowed out, there was always someone listening and watching. And so, but this is a new phenomenon in China. So I just want to remind people that, so what happened, that was certainly true in these gifts, certainly true in the Cultural Revolution, and, you know, but after Tiananmen Square, things are starting to let go, loosen up, going in the right direction, more and more intellectual freedom, freedom of expression. You know, there was an experiment, Mao let 1,000 flowers bloom, but the first 200 were saying the wrong things, so they squashed that. But, kind of off the knees. But seriously, it was going in a certain direction. Now it's going in the reverse direction. So the thing, United States, Europe, everybody else should think is, what's going to be the long-term arc of what's going to happen? Europeans could look at, or China could look at the United States and says, well, look at what the United States has been in the last 3.5 years, 4 years. You know, oh, that's the new United States. Boy, we shouldn't trust the United States ever again. And so we should think about this. What's the long arc of what the United States hopefully will be doing? What's the long arc of what China will be doing? And can you not only rise above the gathering storm, but weather the storm? And so there's something we and Congress should think about too.
Sig.
Phil, let me just piggyback on the comment about the business world. As was pointed out, there in the business world, you have the benefit that you make your decisions based in the end on finances. You know, in business, you got to make money. And so, as you said, you pick the technologies based on what you think the potential is to make money. Let me just tell you, and I'm sure you know that, in the government, that's very, very different, and particularly on the protection end that I was mentioning. You know, Steve had to fight with that when he was in the Department of Energy, and that is certainly my experience with Congress was often that Congress doesn't mind to spend $1 million to make sure that not $1 of taxpayers' money gets misappropriated. And so you wind up with a totally convoluted system that's not based on the bottom line, a financial bottom line. So for example, during my time as director, I tried to learn and take from the business world the whole idea of continuous quality improvement or total quality management. But in the business world, that was also based on the bottom line, that you got to satisfy your customers and you got to make money. It didn't work on the government end.
But you know, it's something else you said, Sid, which is, you know, you had to hire the best scientists on the unclassified part to create some secrets that were worth keeping. Think about what the universities do, and I think as a microcosm at Stanford, and I think that the top 2 or 3 battery people at Stanford, they're all Chinese. Andrew Ng, Fei-Fei Li in machine learning, they're Chinese, born Chinese. Okay, and you start going down the list, and it says, is this the last generation of those faculty members you want? Yeah. Because if you continue this, you will get your wish. Okay, so the very things that the U.S. government rightly is worried about are the things that have been created by immigrants in a free and open society. And so you have to balance all the good that has done and is continuing to do with trying to figure out how to do, how to protect things. And so this is the real serious debate. And one hopes that we don't exhaust all possibilities before we do the right thing.
Andrea.
I think we all agree that what's happening is really misguided and dangerous. So I guess the question is, what are we going to do about it? What can we do about it, right? And I'd like to suggest something, just throw it out there. So I think it would be very helpful if the APS, in cooperation with other scientific societies that are facing the same problem, come up with guidelines for researchers. Okay, this is how you should handle things. These are the guidelines. This is proper behavior. You should follow this. This should be done maybe in consultation with the FBI, okay, or people who are in national security. It should be done with universities. I mean, universities have a lot to lose from this. Universities are reacting, often overreacting in individual cases. But when you think about it, the devastation of research means a lot of loss of grant overhead. It's pretty bad for universities. It hurts their reputations and it hurts their financial bottom line. And so I think it's something that if we could get together and come up with strategies to fight politically, but also I think guidelines for researchers that could make a big difference.
Yeah, I think it's important to realize that it's not only the universities that have a lot to lose. When you hear that scientists who work in the national labs now almost at the point where they can't go to conferences or engage in collaborations with research groups in China, that's the nation doing the nation's business, having a lot to lose as well. So I agree. I want to fold what you said, Andrea, into one of the questions that just has come in, which is that we've been talking a lot about graduate students, and possibly because that's because there's a lot of professors sitting up here. But to expand it to the experience of the rest of the research community, not just junior people like postdocs and graduate students, but also the rest of the professorate and people also in companies and labs.
I was talking about that. So when I was talking about the level of fear, that was professors. Yeah.
And it's basically
the very senior people in the field.
Yeah, and people who have been exposed to 1,000 talents, for example.
Well, two were good friends of mine, one in chemistry in Berkeley, one in material science, and were students of Charles Lieber. They are terrified. They're Chinese. They were born in China. They are terrified. They've been terrified for a year.
And again, I can tell you that we get a lot more people of Chinese origin applying for jobs in Europe than we got 10 years ago.
So this is interesting. Interesting point. It's come up a couple of times because it also came up with the industries that we're actually helping European industries by placing restrictions on U.S. industries, and so I'm wondering whether it's a little hard to tell whether that means that the Europeans are just as concerned about this as us, because the thing that occurs to me is that this isn't something where we're in different camps. I mean, we do have different governments, and we have similar systems that operate at maybe somewhat different speeds, and so the kinds of fear and the reactions of governments here are probably going to happen anywhere. It's simply we cut down you cut down communication and free exchange of ideas in research, and it's kind of disease that spreads. So I'm wondering about that, and maybe Peter, you could comment on that with the UK perspective.
Yeah, I think we could see echoes of it spreading, and in particular, since about 2017 in the UK, there's been a real shift in in the way that we're developing policy, which will ensure both national prosperity and national security. And this is called the fusion doctrine. And what we're trying to do is it's nothing to do with fusion energy. The fusion doctrine of fusing these two concepts together. And in particular, there is a fear of China and of foreign direct investment into emerging technology in the UK. So it's become a dominant influence, and many of you would have read about the struggles we've been having with 5G and Huawei, for example. And so there is a kind of contagion of these kinds of fears.
And you know, there is the idea, the real fear that if you're invested so heavily in your national infrastructure in things that can only be supplied by China, then in a sense they own you. They can turn it off. I mean, what's the concern there?
That's exactly right. A fear that you no longer have control of your destiny, that critical national infrastructure is at the behest of somebody outside.
May I comment on the issue of the fear of China? So in my business, you know, which is primarily the nuclear business, I find it sort of peculiar. At this point, I still go to China a lot. I've been to China 39 times since 1994. I've been to Russia many more times than that, as it turns out. I still go to China today, and I work with their nuclear people in the nuclear complex, including the nuclear weapons complex. My colleagues who were director of their Los Alamos, you know, back in the 1990s when I first went. And so the point that I want to make, there's actually a place and time where even with your competitors, you want to collaborate. And I couldn't help but think this morning when Steve Chu was talking, so we got global climate change. Guess what? In the global climate change arena, you know, so if the Chinese actually learn something for us, for heaven's sakes, that's good. And the area that I've been working with China is, for example, in the area of nuclear power safety. You know, the United States has been the preeminent place for nuclear reactor safety. Well, we're losing our ground and our impact in the world, and the Chinese are moving up. Well, you'd like them to take over that mantle. And so even if they steal things from us, for heaven's sakes, if it's related to nuclear reactor safety and methodologies, the same goes for nuclear security. I've spent a lot of my time, China and Russia, related to the security of all nuclear assets, from the weapons to the materials to the facilities to the people. If they take some of our methodologies, that's good. And so I've worked with them. I work with them on North Korea. I've been to North Korea a number of times. When I first came back from North Korea, I stopped in China, and the Chinese essentially said, no, North Koreans can't do this. And I said, no, the North Koreans can do this. They can build a bomb. This was 2004. So we still have annual collaboration with the Chinese to sort of get a common understanding of what's there. And then similar, the story with Russia is even longer than that as to how we've worked together. So there are areas, in spite of the fact that we're competitors or whatever you want to call the relationship, there are places where you need to work together where it's for the benefit of the world. And that's the one thing we shouldn't lose.
I think there's an element of that you know, the influence of China is, of course, in large part because they are a very populous country. And therefore, they just through that, when their economy grows, the whole world's economy grows. They're a big part of the world. And Steve's addition of 3 new points on their overall S&T expenditures to bring it up to date shows that while we were asleep or watching the Super Bowl, the Chinese went from, well, they're catching up with us, to, wow, they're like way so far ahead of everyone, it drives this question of, shouldn't this already happened? This is reality. It's on the ground now. Shouldn't this drive a higher level of cooperation? Because what we most want is that they end up understanding that the values that we hold dear and how to make expenditures in science and technology pay off for everyone is something that they should embrace as well. We don't want to isolate ourselves from them right now. It seems like the worst possible time to do it.
Well, I wouldn't. Yes, they're heaviest right now in funding, but actually, invariably, they're going to be a leader in science. And there's no doubt about it. There's 1.4 billion people. A lot of them are really hardworking. This is a very good combination. But I think still, if I look at the graduate education in America and to a certain extent Europe, my friend Peter over there is going to get even with me tonight, but we're old atomic physicists from way back. I would say that the free-spirited, free-thinking challenge, dogma challenge, what you read in the literature rather than memorizing what the paper said, is something that runs very deep. And that inculcation actually flourishes best on the long term in a democracy. And this is why American trained graduate students are truly inventive. And we should not lose sight of that. We just want to keep them. We don't want to push them back to China. And we don't want them, England to scarf them up either. I'm trying to get them. But seriously, so these are some of the issues. Now, I also don't want to sit here and wring my hands and wet my bed. And that's all we want, because like Andrea, you want to put in some positive things. And also, Sid, we've all mentioned positive things. Okay, so going back to the education, and also you mentioned, you said, well, when Chinese students come here, we should be sensitive of what they want. First, I propose in the talk, but let me elaborate. There should be a developed ethical standard that we teach our faculty, we teach our universities. The national academies, the professional societies can rally around that flag. We will ask all people who really want to be full collaborators in this to aspire to the ethical standard, to enforce the ethical standard, something else. Actually, in different countries, there are different points of view, and we learned this in the LIGO/Virgo/collaborations, that there are different approaches, and there's not even a uniform ethical standard in the United States or Great Britain. We have to teach our students and postdocs an ethical standard. Stanford University has in the medical school, I'm half in the medical school, half in physics, we have a class, mandatory, of ethical standards. And so it goes both ways, and then we have to communicate that, because it's not okay for a graduate student or a postdoc to take someone else's data in your group or another group to send it over to a friend. That is not okay. It shouldn't be okay to take any data from the group unless the PI says, yes, there are collaborators before we, 2 or 3 years before it happens. That's devastating to a small group. And so these are ethical standards that we can all gather around. I think it will give Congress comfort as well, that you say, we're with you.
I'm glad you brought that up. Also, Andrea started that conversation, because that's actually also one of the questions. It's definitely something on everybody's mind. What are we doing to teach good ethical hygiene? I guess there's just so many things that you need to understand are supporting good science or are antithetical to good science. And we have to teach it explicitly the same way that undergraduates take expository writing. And hopefully it will stick a little bit better than the writing skills.
It's actually different in different fields. I mean, Phil, Peter, I are in atomic physics. There's one thing about atomic physics. Atoms in China and Russia and the United States really behave in the same way. They're deeply the same. In biology, I learned the expression, and in the early 90s, I started learning biology, and I heard an expression, people would say, in my hands, this is what I get. I think, in my hands, is that science? And as I went into material science, when I get back out of the Department of Energy, I'm finding out that most of the material scientists who publish papers, the ethical standard was you cherry pick your data and you publish in the papers the absolute best results, which I refuse to let anyone in my group do. And not only that, I refuse to publish anything unless it's repeated a number of times so you have real confidence.
Typical data.
Yes, the quote typical data, the joke of typical data. But if you're, let's take the extreme, if you're in precision measurements, someone's going to come after you, and you're going to have to get it right.
Well, they do blind data, which is the ultimate test that you're not cooking the books.
Right, and they learned that from high energy physicists, because the data was so sparse that they wanted to take care of the wishful thinking. And so these ethical standards actually vary from field to field.
And this question of, setting ethical standards, and in the context of this conversation about the international competition and even the China sensitivities, it seems unless you can get the Chinese in particular, but all of the countries where you want this freedom to collaborate, to agree in a common way to those ethical standards and the enforcement of them, not just at an institutional level, but to some extent, with some rule of law support for them, not contract law per se, but something like that. I think you're going to struggle to get Congress, in the United States or ultimately in any other country to say, well, that's great that we have these standards here, but if you really want these international collaborations at any scale, or you want the freedom of movement among these things, then the ones that you worry about have to decide that they're going to elevate themselves in a public way to comport with those same standards. So if we're going to have these societies coming together to do that, we can get the European ones and we can get the American ones, but unless we get essentially the counterparts in China to stand up and have the government endorse that as essentially something that they support, I don't think it'll provide much relief for the current concern.
Yeah, I just want to reinforce that one. I think you can't do this as an individual country, and the international alignment in these things is essential. And there are mechanisms for doing this. For example, within physics, you have IUPAC. IUPAC could play a role in this.
The rules that they made were already told when I was in university. So it's a long time that they had this kind of rule.
And if we go beyond physics, of course, then we have ICSU and the inter-academies panels. And I think these need to be, APS could provide a lead in terms of working with these wider organizations on ethical standards and appropriate behavior.
But if we worry that there's some coercive effects in the way, particularly, in China, that the students and the faculty are not, they may personally, endorse these things. They may even learn them in the United States or Europe over many years. But if they go back and there's essentially some coercion or corrosive processes, whether it's monitoring or financial incentives or, bank accounts on their parents or whatever it might be, if those things, are overriding their individual commitment to these things, then the whole thing won't work. And so I think it has to become more of a transparency-driven thing, and it has to be uniform across all the countries where you want this freedom.
I think there's already a kind of example of that we heard today. I just want to bring it up, and it was just in passing that David Reitze said that when he was invited to the Hill to gloat about the LIGO results working, and then came back later to talk about collaboration with India for making an additional interferometer, that the comment was made that it's a good thing you're not coming to ask us to put one in China, and maybe it was being made in jest, but it was being made for a reason, even if it's in jest, and that is that China is not considered necessarily a fair and open partner. And that's already driving the idea that countries would choose to not invest science infrastructure in China if China is not going to play fair. That's the sort of thing, since they want to be an international player, could drive changes. That's the kind of pressure that could drive changes.
But I don't think fairness can be done on a case-by-case basis. So unless you can elevate this to something, much like, you know, when there was the concern about the economic espionage, and finally the two presidents of the countries got together and agreed to stand down on that issue, and that was a huge, you know, relaxer, you know, of tension at that point. You know, it seems like we've now got this emerging, largely because of a similar concern, but not based on that form of nation-state intervention, but here a more subliminal way of trying to acquire this knowledge or gain some advantage. And I think we have to kind of go at it the same way, where the societies, you know, that represent the research interests have to come together and say, hey, look, globally we agree to this. But unless the counterpart, you know, countries and regulators or legislators also agree that that's going to be a sufficient, you know, vehicle to breed comfort, or at least let you go try to rebuild trust, you know, I still think we'll be getting, by innuendo or other means, a lot of coercion that will tend to breed the fear, and that'll all continue to put a brake on all this.
Craig, could you actually expand that? Because I don't think the audience might have gotten the context of your comment about this informal détente.
Well, I guess, I don't know, it's half a dozen years ago now, there'd been a number of years where it was very clear, particularly in the corporate sector, that the Chinese were using nation-state methods to appropriate intellectual property from companies and then passing it through to other companies. And these were not in the defense and intelligence businesses. So there's always been decades, and it'll never go away. Even in that détente, it didn't go away. The idea, look, countries are going to keep worrying about what the other ones are doing in military terms. But the idea that somebody wants to come in and steal, you know, a paint formula for a special kind of paint, and then put a company into business in China and have, you know, controls it. You can't bring the paint into the country, but I can make it here now. You know, that was happening very, very broadly in the United States and elsewhere in the world. And the threat from that was such that, you know, it got elevated to a point where, you know, it was at the top of the agenda for the U.S. administration, Obama at the time, and in a meeting that was had between President Obama and President Xi, they agreed to basically that was not considered a good thing to do. And there was a quite significant abatement of that activity for a long period of time. That lasted right until the beginning of the Trump administration, and then it turned out it was turned back on. But there was no law, regulation, treaty, or anything else. There was just a détente agreement that really made a difference for a while.
Yeah, and so let me add, on the government point of view, there was this informal, let's cool it, keep it down, try to not go into full-fledged cyber warfare. And just as immediately the United States pulled out of the Iran agreement, the UN agreement, the Intermediate Ballistic Missile Agreement, they pulled out of this one. So it became a self-fulfilling prophecy. And so it's easy to make enemies. And so that's, so from the government side, I'm completely in sync and agree with what had happened. And it was just devastating as a former DOE member to be watching this.
All I'm saying is, if you don't do something, you know, to where the powers that be in the governments agree that they want to have this go in a better direction, you know, then, you know, I think none of these things will improve quickly.
So I certainly agree that, you know, it's you need to get other countries to sign on to it. But I think there is a value to developing these guidelines, including ethical guidelines, on our own to begin with. And part of it is so that we can point out we are cleaning up our house. You know, we're doing this. And all the cases, you know, the FBI, all these arrests, they're counting these as wins. They're counting them as wins against espionage. But for example, the 3 arrests on Tuesday, right? It's not espionage. It's scientific malfeasance. And in the one case, it's a visa issue, right? I guess this graduate student had worked for the PLA, right? And now But now she works in the group, she's a graduate student in the group of a theoretical statistical physicist, Gene Stanley. I mean, he's not doing anything dangerous, right? I mean, it's really a ridiculous thing. And so I think, if we do that, then we can really point out, this is not espionage so far.
So ethical standards actually also help us justify whether behavior is appropriate or not. Because
and we can
say
push
these
back
standards
against the fear.
These are known standards, and we teach them, and you can show that these standards were violated or they were not, and that it gives it some standing.
If you're accused of academic fraud, making up data, publishing it, okay, you can lose your job. And so in this other stuff of, someone in the group or a professor leaking someone else's work to someone else without their approval, that too is unethical. This is easy to, there's going to be no debate about these things.
Petra, I think you wanted to make.
Well, I think that is there anything that the other learned societies outside of the United States can do to help you in this?
I think this is what we're talking about, that this is the sort of thing that needs to be done in concert with all of the societies.
The ethical rules, that's something that I consider nearly obvious. So I mean, it's really so much ingrained in the graduate education and so on. So, for example, all the graduate students in the country where I work, in the Netherlands, when they get their title, they have to swear that in the future of their future career, they will abide to the Netherlands Code of Conduct for Scientific Research. And I know that in the UK there is something similar, and so on. So it's not only teaching it, it's also trying to have the personal commitment that wherever they go and wherever they are in the world, they will abide to these rules. Of course, you cannot check it, but you hope that by forming somebody over the years and then by making him or her swear that they will do it, that you do some. Maybe we are too idealistic, but that's why we believe things work.
But by the way, rules are mostly enforced by peer pressure around the world, if you think about it.
And taught by example.
Yeah, these are norms.
Okay, let me switch to a slightly different topic that was suggested by one of the questions, and it involves whether we should be encouraging young scientists. Well, I'll read it the way it was written, although I think I want to interpret it slightly different. Whether we should encourage some young scientists to go into politics. I think I look at this issue from the other side, because I'm sitting here on the stage, and arguably at least 3 of my companions on this stage have gone into politics, at least to some extent. So they'd probably argue strongly against it. But but just as but it's more a question of who are we engaging on the other side in the political debate, and whether the people who those individuals in government rely on for advice have a scientific perspective.
Phil, let me take a part of that question, just change it a bit to say I'm not sure I would encourage the young scientists to go into politics, but I would certainly encourage the young scientists and engineers to become aware of policy and to actually take positions along the way in Washington at some place where they play some policy role. Or at their universities, and more universities, certainly in the United States these days, have classes where you learn something about policies. So I've taught a couple of those at Stanford. So for example, one large class that I taught for many years with former Secretary of Defense Bill Perry was the role of technology in national security. And we had the whole spectrum of learning about science, technology, but policy also, to have a better understanding how science and technology impact policy. I now teach a small seminar course that I called All Things Nuclear, nuclear weapons, nuclear energy, nuclear proliferation, nuclear terrorism. And it's precisely the same thing of looking at policy, technology, interface. And I think it would be very helpful for more of the students to at least become sufficiently aware of the policy issues that are out there so they can be better versed and then eventually perhaps have larger impact.
The one thing I'd say is to answer the question is take the word young out. All right. I mean, you know, I spent, well, almost 20 years at Microsoft with the full support of the company trying to help with policy issues around the world, both in the United States and in many other countries, including China. And I think one of the reasons that I was accepted was, you know, I had a broad perspective about some of these issues. If you take a really young person, they might be smart about, you know, one thing, but they may not understand, you know, how these things relate. And so one thing you don't see are people who are relatively senior people with technical backgrounds that end up finding a formalized way to contribute on the policy side.
I don't know what the situation is in the Senate and here in the United States, but I can tell you that we made a sort of an inquiry in Europe, and the number of people with a science or engineering background among the parliamentarians all over Europe is terrifyingly small.
It's one in the
It's
United
Angela
States.
Merkel.
So I think that we really should encourage bright young scientists to become politicians, because we need them to do wise decisions and to understand when we lobby. Of course, we have to lobby as well, much more than we have done in the past. And we need to learn how to lobby, all of us. So I think that's something that's inevitable.
One of my roles with the UK government is to run a kind of dating agency between the scientific community and policymakers, of pulling people in. And I really do agree, we need a spectrum of people. We need early career people, and we need people with lots of experience. One thing I do with my dating agency activity is that we run a crash course that I call Avoiding Speaking in Martian. Because our policymakers are not really scientifically literate. And we make assumptions as a scientific community about shared value and of language. And so we actually run a crash course before we throw people in to SPADs, science policy advisors, and to ministers. And it's really important. That dating agency activity, by the way, is really very effective because there is an appetite to try to influence policymakers in terms of evidence-based policy.
At the European Physical Society, we are running this spring a course which is a Train the Trainers course, where all the member societies will send somebody who has then to engage to organize at least 5 training sessions on how to talk to policymakers.
I just want to quickly say that a bunch of us visited Congress yesterday, and one of the things we were advocating for was this bill that was introduced to make the F1 visas dual intent. Just want to point out that bill was introduced by Bill Foster, who is the only physicist in the House, right, in Congress at all.
Believe it or not, I don't think I'm a politician. I didn't run for office. And so, but I had a president who was willing to put on a cabinet for the first time a scientist, a practicing scientist in the history of the United States. So we would like politicians to actually appreciate science. And then, to Peter's point, yes, and then teach them how to speak in articulate, broken English.
Universal language.
At universal language. See, in DC, there's the universal. I thought I was savvy and everything, and I realized how naive I was because I thought, okay, money may be the lingua franca of DC. No, it's the only language.
Okay, we only have a few minutes left. There was one question that came in that I thought was sort of thought-provoking, and it did cover kind of an area that we hadn't covered. It's that, let's say that we do have ethical standards and that they're very well known, because I think we actually do. This person was supposing that this is something that we would do. Doesn't that just allow unethical countries to develop a playbook to appear to play by the rules while stealing IP? And I mean, I think that that direct question is not actually as broad as an underlying issue, which is that the sands are shifting all the time. And you know, China, as well as being one of the largest countries and a very technically advanced country, is perfectly willing to morph its rules to continue its objectives.
Let me start. I think I'm an optimist here, and that is if everybody's behaving well and there's few outliers, but they realize they're now outcasts. They have a choice. Now, if everybody's behaving badly, there's no hope. You know, it's like the police department, where there's one bad cop versus 2/3 bad cops, right? There's an issue here. But I think I'm going to be an optimist and state, I think among scientists, we're way on the side of ethical people. And because of that, we can start in a very good, strong position.
Phil, let me take that in just a little different direction. You know, I think it's very important that we think about what can we do, what can the societies do. And so far, we focus primarily, again, on what I call sort of protection of things. I just want to put in the plug for the creating of things. So one of the things that what we can and should do, and you've done it by going around Washington, and Steve Chu mentioned it a couple of times this morning, you know, the gathering before, the storm.
Rising above the gathering
Rising
storm.
Above the gathering storm.
And restoring the foundation. Both have the same
rising
message.
above. So to stress the importance of making sure that we run faster. I came to this country from Austria, it turns out, when I was 13 years old. And what I love coming here is we had a country, this was 1956, we had a country that really depended on outrunning everyone else. And Steve showed the 1957 Sputnik moment, and it was one of those crystallizing moments. And what that moment said is we're going to outrun everybody else and not to try to keep everyone else back. And so I think it's our responsibility to continue to make that point with the politicians is, look, what's made this country great.
And not only that, I still think we have the most original thinkers in the U.S., trained by the graduate schools. And so the most original thinkers benefit the most from free exchange of information. And once you put up these fences and cut everybody off, then it's more equalizing. And so this is not fully appreciated in Congress.
I think this message of out innovating and that how openness in research is the way to do that. You find out what everybody is doing, and then you can out-innovate. I think this is really a great note to end this discussion.
We have 2 more minutes.
We have 2 more minutes. What did you want to say, Steve?
I'm reminded of a poem of Robert Frost. Many of you may know this. It's about good fences make good neighbors. I could not disagree with this more because we are drifting into a world of building fences. And in science, that would be disastrous. But once you build fences, you don't have a dialogue. You don't have trust. The world runs on trust. By having open collaborations and open science, that is an avenue of building trust. And so the very fabric of science and the proliferation of science is the way you build trust. But you talk to people on a personal level. And so this also has to be emphasized. It does run on trust. If a nation state or a group of unethical individuals break the trust and become outcasts, they pay the price.
I just think in closing, to answer the question directly, there's 2 classes of potential problem, and Steve just mentioned one, which is, or both, that if you have an individual or small set of people that are misbehaving, that will generally be known to the peer group. You know, I mean, it's just observable that you know, they're getting too many miracles too quickly. And you can provide that level of enforcement. If you get a systemic thing going on, then, you know, then there has to be some broader community action. And, you know, some kind of disenfranchisement then has to be done at a grander scale. But I think as long as you understand the difference between one or two bad apples and a system that's seeking to disadvantage the others, and you have appropriate ways of intervening against both, then I think you can go forward.
I want to take the opportunity to have the last word here as our shot clock winds down to 0. There's been a lot of three-pointers in the last minute, so I like that. Okay, Sir Peter Knight, Petra Rudolf, Andrea Liu, Sig Hecker, Craig Mundie, Steve Chu, thank you so much. This has been a really terrific session, and I'd like to thank everybody for attending and just point out that we're about an hour away from our medals reception and ceremony that will be across the street in the Willard Hotel. So I hope to see a lot of you there.